would not be 35 euros, and so would 40 euros not be 35 euros. So any value below 35 euros or above 35 euros would not now be 35 euros. So more importantly, this particular test, for us to show, don't forget the hypothesis is a statement about the population parameter. What we'd like to be able to try to show is there evidence? That's where we would go to of the alternative. If we had evidence to support the alternative, is there evidence to suggest that the population, that the true population mean is now not equal to 35 euros? In which case, the only thing that's not covered here in this particular scenario, in this inequality, is that the mean is equal to 35 euros. So this is our hypothesis test. Is there evidence to suggest that the true population mean is not 35 euros? Okay. So stage 2 is to define the significance level, significance level, and this is straightforward enough. It's alpha is equal to 1%. So we have alpha is equal to 0.01. That's 1% as a decimal. Okay. Then what we do is we construct our test statistic. Step 3 is our test statistic. So our test statistic is, it's a t-statistic because our sample standard deviation is known. It's a single sample test because we've only got one sample. So our test statistic for a single sample test is t is equal to, it's equal to the evidence minus the null position, okay, divided by the standard deviation of the sample divided by the square root of n. In our case here, our x bar is our evidence. Our x bar is 37.59, so it's 37.59 minus mu. Okay, that's what we believe, where we believe our distribution is centered under the null position. Okay, so under the null position, which we assume to be true, Okay, we believe that mu is equal to 35. So it's 37.59 minus 35. Okay, divided by the standard deviation S. Our standard deviation is 4 euros. See, our sample standard deviation is 4 euros and 98 cents, so it's 4.98, which needs to be divided by the square root of our sample size, and our sample size is equal to 22. So our test statistic t is equal to, in this particular instance here, well, it's 37.59 minus 35 gives us 2.59. And that needs to be divided by 4.98, which needs to be divided by the square root of 22. So all I'm going to do is I'm going to just do the denominator first. I'm going to do this piece here first, which is 4.98 divided by the square root of 22. Gives us a value of 1.0617 to 4 decimal places. So this gives us 2.59 divided by 1.0617, which gives us a test statistic of, okay, so this number here is 2.59 divided by 1.0617, gives us a test statistic of approximately 2.44 to 2 decimal places. So this is approximately 2.44 to 2 decimal places. Okay, so actually what we're saying in standard unit terms, the evidence, the x bar, seems to be a distance of 2.44 standard units away from the hypothesized center of our distribution, which is 35. Okay? The question is this far enough away to be significant? So the next step is we need to calculate our critical values. Okay, the critical values associated with this particular t distribution. Okay, because we've generated a t statistic. So what we'll do is we'll calculate our critical values. Okay, so that's the next step. Step 4 is to calculate our critical values. Okay, our critical values. So this is a t statistic, so we're dealing with a t distribution. Okay, so it's a t distribution. It's a symmetric distribution that's positioned on 0. And what we're going to do is, okay, well, we know that our alpha, our significance level, is 0.01. Okay, but look at our alternative. Our alternative is, sorry, the significance level is 0.01. Okay, that's the probability that we're willing to accept, or we're willing to rely upon when we incorrectly reject the null hypothesis. Okay, but our alternative is not equal to 35. So I don't care whether my test statistic is out here or whether it's to the left. In either case, if it's far enough away, either to the right or to the left, that'll be evidence to suggest that there's a difference. But what we need to do is we need to put half the area in both of our tails. So what we need to do is we need to figure out, I suppose, okay, we need to put 0.01 of the area must be in both tails, or the totality of the area in both tails must be 0.01.